So whenever we, at any of the desks, whoever's working, the forecaster, whoever issues a segment, it'll be sent out on Twitter. So that's pretty cool. But for this day, this severe turbulence segment was sent out. It was from between flight level 30,000 to 38,000. And then on the right, I captured the PIREFs that were during that time frame that would be on the website for the AWC. And so with the different tags I put up there, that's what was actually came in. If you toggled on that at the time, that's what was reported by the pilots. So the first one here, MLF, this is for near Milford, and that was for severe turbulence at flight level 34,000, and that came in at 1750 Zulu. Then to the right, we had HVE, that's Hanksville, near that region area, and that was at flight level 33,000, and that came in at 1736. Now the one below it, on the southern end of the border there, near Arizona, on the Arizona side actually, that's TBC. That was near Tuba City, north of there, and that was reported at severe turbulence at 31,000. Then what occurred after that, the next forecaster came in, and then it was time, of course, to do either cancel the segment or extend it. And both Chris Jacobs did an excellent job on doing the first segment, and then Amy McPherson did the second one and extended it. And it was great work for both of them on doing this those segments issuing for safety. But anyway, that's what I'm showing here, and you'll see with the other slides coming up that they had good support for extending, for issuing those and extending them. Okay, for this slide on the left, we have GOES 16 Viz, and I put on the icons here. I made little icons for Sierra Pirates were pretty close to where they were reported, and this should give you a reference. But in the red oval areas, you can see over Utah, in Nevada, you have a nice trap lead mountain waves, and it's showing a nice fingerprint or scallop depiction, and you usually see that with mountain waves. That's a good signature. And then on the right, that picture was done at 2146Z, so it's a few hours ahead of that, but it's a good capture. And then on the right, we have the GFS 2 to 300 millibars. This is a shear magnitude image that we use in wind speed with heights. And as you can see in the red oval, we have northwest winds. That's good cross-barrier flow for the mountains in Utah. And those 50 knots, 55 knots are good wind speeds. That's what we like. I typically will see. You know, my eyes light up or ears perk up, whatever you want to say, when I see 50 knots. But anyway, also the colored image is the shear image, so that's a good indicator of that color there, as is showing that you're going to have possibly good shear going on, which results, of course, in turbulence. Now, with this, we have on the left the NAM. Both of these are NAM 80, 2 to 300 millibar bulk shear. One's at 18Z, and then the one on the right is at 00Z. Again, I put the PIREFs on there from earlier. The one at Milford in Hanksville in Tuba City. And you can see on the one on the left, it's showing good indices for possibly moderate to severe turbulence for sure. Still strong winds out of the northwest. And then 00Z. As you'll see later, there was a nose of a jet core coming in on the west side of the state, northwest side of the state of Utah. So another good dynamic setting up there as well. But as you can see, the image is still showing a decent possibility for turbulence, for shear there. Then I had 4 to 300 millibars. Again, the same time frame, January 27th. The one on the left is 18Z. The one on the right is 00Z. And they're showing it's showing weaker here, but still you can see that trough in here with that's moving through, and then the strong northwesterly winds in the at that level as well. So that'll be still good indices, you know, for turbulence coming up, but. That's what we looked at as well that day. Now here, this is the NAM on both sides, 4 to 500 TKE shear buoyancy product dispensation, and this is at flight level 18 to 24,000. Again, the one on the right is 18, and the one on the left is on the right. boy, I get them mixed up. The one on the left is 18Z, and the one on the right is 21Z. And here they're showing pretty weak shear, which is good in this way because it'll help the vertical propagated waves to not get torn up as they try to form. So as you can see, that they're a little bit stronger here, but still that's in the low end of our scale here for the indices there. And then this is NAM 250 to 300, same indices here, except for a different level in flight level 30,000 to 34. Again, slide on the left is 18Z, and the slide on the right is 21Z. And you still show the one on the left there is still showing a weak shear. It's starting to increase somewhat here, by 21Z. So with that trough moving through in northwest winds, so it's a little stronger, but still weak there. Now this is these products here. The GTG is the graphical turbulence guidance, and the CAT EDR is clear air turbulence eddy diffusion rate. And this composite here on the left is at 21Z January 27th from flight level 30,000 to 34. And then the one on the right is a little different, is GTG again, but it's for made more specifically for mountain waves. So as you can see in the red ovals, the one on the left here, you have a nice indice for potential for moderate, maybe isolated severe here with the indices yellow. The orange is 30 to 35 in that ballpark for those indices there. And it's a little higher here, maybe about the same there for the mountain wave. So they're shown with a composite there. Again, the mountains up here is the Kings Peak. That's one of the higher ones, around 13,500. But anyway, it's starting to show some chances for moderate to severe, and you would definitely expect moderate with this, and they were getting it. Now here's the same composite, except for it's a little at 0Z, and this is at flight level 30 to 34. And again, in the red oval, here's the pirates that were done earlier. These two on the left here, Milford and Hanksville, were at 18Z roughly, and then one Tuba City, remember, was at 15Z. And that really verified well there with that one on that side. And then I thought this one as well is verifying, it's showing good indices. And again, definitely moderate turbulence up along the mountains along the Kings Peak there in the northeast section of Utah. And then for this one, it's just same indices as before, the GTG CAT EDR, but just higher levels. 21Z on the left at 34 to 39,000, and then same thing on the right, except for it's the mountain wave. And you can definitely see, the indices are getting a little stronger, and definitely with the mountain wave, they're really strong bullseyes here throughout the I'll say the middle Wasatch Plateau, and then also the Kings Peak up there, and also maybe just southeast of the Tushar Mountains. But yeah, you'll see these. You definitely want to have your look at things more closely, and they're definitely showing there's definitely good potential for moderate to severe turbulence. And this is, again, the same indices except for the 34 to 39,000, so slightly higher. And they're getting, the ones on the left, the CAT EDR, is showing good indices for at least moderate turbulence, maybe isolated severe. The mountain wave was a tad stronger, and they're showing moderate to definitely, I'd look for severe in here in the red ovals, especially in one in the central or southern portion of the state. Now this is another indice that we use. This is the RAP, vertical wind shear squared. It's part of the shear tools. Anyway, this is done at 200 to 250 millibars and at 21Z on the left, and then 00Z. And you can see you have a nice bullseye here. Again, that would make sense as your system is moving to the east with your trough and the nose of the jet that's pushing in. You'll see later on the western portion of the state. And then by 00Z, they're showing it as it moves on to the east. So again, all the indices are pointing to continuing moderate to severe turbulence. Now here's our low level, more or less our boundary layer winds. This is the RAP 1,800 to 2,700 feet AGL winds. The one on the left is 21Z, and then the one on the right is 00Z. And you can show the good strong winds in the lower levels. 50 knots, 45 knots at 21, and 00Z just strong, maybe a little weaker, but still that's good. A good direction and good wind speeds. So the importance of this, it'll help to vertically propagate any waves to. And now one of the papers I had read a while ago by Dehne, he talked about how critical it is to when you had that wind flow going over on the west side of the mountains. As that goes, it goes from subcritical as it transitions to the lee side. If it's strong enough and everything's lining up right, it'll be supercritical, and that's typically what you'll start getting the hydraulic jumps or the breaking waves forming. So these are one of the good indices we like to see to help with enhance the possibilities of moderate to severe turb. Here's 250 millibar winds at the RAT model, and this is at 21Z at the 27th. And again, here's that nose of the jet I was mentioning before that's coming in. So another good dynamic that will help to cause turbulence, and with that right front quadrant jet core approaching. And then at 00Z, it's not going anywhere. It should be moving farther inland. Farther inland to Utah State. Then here's the RAT 300 millibars. This is the 28th at 00Z, and you can see the nose is definitely way down into entering probably just barely north of Milford area where that severe pirate rub was reported earlier. And I was just showing on the right the CAT EDR at that same time frame at 30 to 34,000. Roughly the same height. It is pretty close to the same height. So again, they're showing moderate turbulence and maybe isolated severe in there. Here's our soundings. I wish I could have got soundings for the actual areas, like in Milford or Hanksville, where those pirates were. I just wasn't able to do it at the time. But this is over Salt Lake City, and this is upstream of the flow. So I think it's a decent representation of what was going on. So at 00Z, the winds are pretty weak on the left side, as you can see this profile. And then on the right, this is 00Z. The one on the left is actually 12Z. The one on the right, it would be the one in the afternoon. So this is showing, again, forward wind shear regime in it, and with it you have some stable layers. They did, with the general rule, they like to use a 1.6 if the winds are 1.6 stronger than the 2,000 feet or 2,000 meters above your ridge top, the winds, then you'll likely have a trap wave below, and that's what we showed with the satellite early with that visual one that I showed you. So that's what the stable layer here was showing. So that was a good indicator. Now here's a cross section. This is used in the NAM 12, and this is January 27th at 21Z. The stuff in the yellow, actually the green, the color image is the omega, and then the orange is like I'm showing here. That's your potential temperature, and then the wind speeds are in blue. And if you can see, this is west, this is east, and again, east would be Nevada. So going west to east, but anyway. You see this nice couplet here. You're strong with your omega, strong upward vertical motion, and I think the thing that really speaks out to me is how far or how much this vertical motion it would punch through your trope here. Your trope is with the potential temperature lines are compacted, and that's your stable layer, and that's showing where it's a good indicator where your trope is and your trope height. So it's showing right around 300 millibars, and that's not surprising, where your wave pushing through there, where you'd expect to see severe turbulence, and that was verified, with those three reports of severe at 33,000, 34, and 31. Now here is the same cross section, except for it's at 21Z, and then the one on the right here is at 00Z. And you can see your potential temperatures here. It's hard to see. You'll see with the WRF coming up, it does a better depiction of showing with the higher resolution hydraulic lift. Anyway, with your potential temperatures here, it's real stable here. It's compact, and they're showing that here. But then at 0, you can see they start separating, and that's usually a good indicator of instability. So you have that layer there, and instability, then another layer stable, then instability, a little more instability there as well. So what I think is trying to show is good areas for showing turbulence. So that's what I got out of here. And this peak in here, Richfield, Utah, where this couplet is, the strong couplet of upward motion and downward, is right about in the middle of, like in between where those pirates were, between Milford and Hanksville. So right about in the middle of our cross section here, where I'm pointing up here, just for reference. Now the next slide's coming up is we'll be using the WARF 1 kilometer and 3 kilometer, and 3 kilometer will be your blue line here, north to south topography cross section done at 111.6 west. Then the green one's a little farther west. That's going to be 1 kilometer at 112.1 using the 1 kilometer WARF, and then the red one is I'll use the 1 kilometer and 3 kilometer east to west, and that's what I'm showing there at 38.3 north. And then the last one is the purple one here, or pink. Well, my daughter would say purple. Anyway, that's 1 to 3 kilometer, and that's southwest to northeast topography. And again, I put on the for reference the where the pirates were, Milford, Hanksville, and then Tuba City. Again, here's the Tushar Mountains, and then the Henry Mountains located close to there, and then you can see the Wasatch Plateau. Hope I didn't butcher that too much, but anyway, and then that section where we saw earlier where they're showing that strong mountain turbulence over here over the Kings Peak. But anyway, just a little bit of reference for you. Okay, here with this one, starting off with this is on the left. You have WARF 3 kilometer north to south topography cross section, and so the north is here, and then the south obviously is to the south, and then you can see your PIREFs just for reference, and then they show the topography, the heights down here in meters for the different mountain ranges. On the right, we have the WARF 3 kilometer cross section north to south. In the black, you have the potential temperature lines, your theta, which are good. They help to show the breaking waves or the instability in the unstable areas. And then in the X wind is your that's your color that's in blue, and then those are your positive U winds. So if they're positive, they're from the west, and you can see they're positive, they're blue here, so they're from the west. So that's this for reference for you. But anyway, you can see this nice when you look for a hydraulic jump. It's kind of like a I think of like a surfer wave, or or like a big check mark. You know, you start, you go down, then go back, and then go straight up. So this is showing. The other ones will show a little bit better. Looks like it's trying to form, but again, this latitude is roughly around where the reports were 38. That's right around in that ballpark, 38, 30, 39, a little farther north. But anyway, that's we're showing a nice hydraulic lifting here. That's showing that there's definitely a good possibility for some moderate severe turbulence with that. And I thought what was interesting with this, remember we talked about that northwest jet that's coming in, the jet core. You see the speed increase here that's coming in. So that's I was curious to see how that would enhance the hydraulic brake or just what. But anyway, the speeds in here is meters per second, and that's roughly this dark here. If I was writing it down, it's like about 60 knots. Now the next one here is the same cross section, except for the one on the left is the WARF 1 kilometer. It's done at 112.1, and then this is south and this is north. The south, of course, would be near the state line. The state line is between Utah and Arizona is right around the latitude is right around 37, and then going north. But anyway, this one here, we had that report near Tuba City, and the latitude for Tuba City is right around 36 point, I can't remember, 5, 6, something like that. So I thought this was trying to show something there, and that's about when that's when they got that first severe report at 15Z. So that might have been a indicate trying to show that, but that's definitely over to the farther. You can see that this area here, as well as with your 3 kilometer on the right, it's pretty close to the same cross section, just moved over the longitude a little different, a couple degrees, but not much. Anyway, it's showing that as well. So I thought they were trying to, it did a decent job of showing that there was something going on there. Then this is the cross-section wharf, 3 kilometer east to west topography. This is a 38.3, and that's real close to where Milford and Hanksville, their latitudes are at. And here's the wharf, 3 kilometer potential temperature again, and your X wind, and you can see definitely. Here's that hydraulic lift I was trying to show you before, right in here. So yeah, that's a good indicator. With Joanna talked about that subcritical transitioning to supercritical, and you typically will get your break then. So anyway, that's excellent cross sections. These were all, the wharf was all done. I want to thank Emily Nyber for doing those. She's in the Arctic test bed programmer up there. Thank her for those. But anyway, these these are pretty close to between Hanksville and Milford area. Well, actually, Hanksville, which came in at 18Z, that's when we got the severe pyro at Hanksville. So this is real close to Hanksville area region, as well as Tuba City is the same longitude. Anyway, going on to the next one. This is your wharf, 1 kilometer. Again, this is at 15Z, and then one on the right is at 18Z, and then both of these are east to west orientation. So again, it's just 3-hour difference, but you can see that the 1 kilometer really shows that the hydraulic jump, and so does the 3 kilometer just as well. I think maybe the 1 kilometer may be a little more noisy, but definitely you can see how it's punching up through, that wave is punching up through the tropopause. And again, you have that strong, you got, that's 30 meters per second with your winds again. This is your X wind again, your U wind. So that's, again, around 60 knots. So anyway, that's again, both are showing good indication of moderate to severe turbulence. That potential is there. Now this is your southwest to northeast cross section. This is wharf 3 kilometer on your left at 18Z, and it's done from 113 through 110. It kind of splits. It's nice right through between the two reports. Again, through the mountain range there. This is the Wasatch Plateau in this region here, and the two Shire Mountains are in here. But and I believe these are the Henry Mountains in this region. But anyway, you can see on the right, on the 3 kilometer, again, you have potential temperature with your black lines here, and then also your wind speeds your X winds here are all showing positive. So, excuse me, they're from the west. Again, look at this hydraulic jump right around. Again, the same latitude as excuse me, not Milford, but it's covered up on me here. But anyway, as the pipe was mentioned before, and then the other ones are showing there's not quite as much a break in here, but again, it's showing a ripple going up through. Again, I'm not sure, if more of this is due to that jet core that's approaching from the west coming in. But this is definitely a breaking wave here, and this one looks like maybe it's one trying to form, which would be near more towards Hanksville. Okay, I think I went there. There we go. Okay, this is wharf 3 kilometer north to south, 18Z, and as you can see, same as before, it's at 111.6. And here's your wharf 3 kilometer, just like before. But the only thing different with this is the same potential temperature, but instead of using the X wind, now you have the Y wind. With your wind vectors, you have X and Y. Well, this is the Y one. So positive or V or your V one. The positive V winds are from the south. If they're positive, that means they're from the south, and these are negative, so they're showing northerly winds. Anyway, the color scheme, again, meter per second, and this is roughly around 60, 65 knots with that color in there, that dark purple. Yeah, it looks like purple to me. And anyway, you can't miss that breaking wave in here. And then you look over here. This is another one trying to form. Looks like another ripple coming off of the mountains in this region here. But I think they're definitely a good indicator. This one is definitely pushing up into the tropopause. Now here's the WARF 1 kilometer 15Z, same cross section except for it's 1 kilometer, and then this one here is the one we just saw previously. So I'm just showing you.
Terry?
Yes.
Can I pause you just for a second there? It looks like somehow you lost control as the presenter, so let me just give it back to you in just a second.
Sure.
Or you can also request as well.
Do I exit out of here?
You can stay on your presentation there.
Okay.
Actually, just going back, I have to find your name. Actually, if you want to do the bubble there and just drop down and request to present.
Let's see here.
And then just as kind of a time thing, we have you for just about 3 more minutes here.
Present. I'll go click present.
Uh-huh.
That work?
See if it comes through here. Let's see here. I'm going to try to pass it to you too. All right, you should be getting a little approval. Like I said, we've got about 3 more minutes left up in the half hour there too, so we just want to make sure we can get you in there. Hopefully you got the invitation?
I think so.
Okay.
Can you see me?
It may be slightly delayed.
I moved the screen to the next one. Did you see that?
Actually, still have that you need to approve being a presenter.
Okay.
But it might also just be delayed on this end.
Because last time all I did was exit out and then I clicked present.
I'm just trying to get you back.